Okay, amazing. Welcome everyone to the first workshop of the Evmos-Covalent Hackathon. Today we've got Leibing here with us from Covalent, who's going to do a workshop in the Interchain Data series on the Evmos On-Chain Data with Covalent API. So it's great to have you all here. I'm going to hand it right over to Leibing for a great workshop coming up, and I'm going to be sending some links in the chat. And if you have any questions, please just message me. I'm going to be around here. And if you have any other questions about the hackathon or any other questions surrounding your work, please do feel free to book a one-on-one call with me. You can get a hold of me on Discord, and via email. So thanks, and I'll hand it over to Leibing.
Thanks, Emma. Hello, guys. Hope you're excited to learn some stuff about Evmos on-chain data. Hi, Arindam. Nice to meet you.
Thanks, man.
Where are you guys from? Where are you from, Arindam?
I'm from India, and I'm right now in my hometown. I'm in Kharagpur.
Oh, nice. The Covalent team is going down to India at the start of December. Actually, we're going down to East India in Bangalore.
Okay.
Yeah, it's quite an exciting event if you happen to be around. But yeah, so today I'll just be covering with you guys like how to get on-chain data from Evmos, right? So what is on-chain data used for? Have you ever wondered how to build a wallet? This is a actual, Rainbow Wallet is a really good wallet project, right? To build something like this, you need your token holdings. This is, you supply your address to it and they give you your token holdings. Or have you thought about how you can build a chart like this, where it shows you the liquidity, the volume, as well as the price of each of the liquidity pools on Uniswap? You might know that the data is, you can kind of get the data from the Evmos Block Explorer, right? Which in this case is evm.evmos.org. And yeah, there's lots of data. There's addresses, there's transactions data, and it also shows you the token that this random person holds, which is like some USDC, some osmosis, etc. And if you're familiar with getting on-chain data, like if you had written Solidity code before, etc., you will know that you can kind of call the functions on the smart contracts to get the data. And you will know that you can also use a JSON RPC method to get, all sorts of data, right? If you want to get balance, you can get the use this method. If you want to get the number of transactions of an address, you can use this method. And if you want to do any kind of like post, I believe you can also call ETH call. So these are all ways to get data. But then what then is Covalent's product? Like why do we feel like we need to still have an additional service? And that's what I'm gonna try to go through with you guys today, and hopefully you can take away some stuff. The main problem that we are trying to tackle is that when you get data from using some of the previous methods that I've explored just now, like JSON RPC methods, you tend to find that it's a very point query approach. Point query being, I want one piece of information, I need to specify that I want that piece of information, and I only get that one tiny piece. For instance, let's say I wanted to get my wallet balance. I need to make one call supplying the contract address for, let's say if I know that I own uni tokens, I need to supply that contract address, and one call gets me one balance for that contract address, right? What if I hold 100 tokens? I need to make 100 calls. So this is an example of a data challenge. Another reason is also because if you want to get the data, typically you need to run a node, or you can query a cloud node provider like Infura, etc. Running your own node is prohibitively expensive and outside of the hardware capabilities of most of us. I believe it goes up to a couple of TBs in terms of in terms of its needs, like hundreds of TBs or something. And also, if you're querying the data through a database, you end up in a situation where there's lots of complex queries. And sometimes, given the nature of blockchain, it's unstructured, and thus it might be inconsistent. So, which is why we focus on the unified method. By unified, we mean that we have a similar request and response format for each of those EVM compatible chains to over 40 chains that we support, so that you don't have to think about how you're going to get like, very common things like balances data from Evmos, or like how you're going to get balances data from Polygon. And mind you, they will be different if without this kind of unified solution, right? Depending on which blockchain you go to. So it's really a service for you to get a standard series of data really quickly using our standardized endpoints. And as you see here, we see ourselves as the data layer where the blockchains produce the data, which is exposed to the nodes, and then supplied to the end product, consumer-facing apps. Yep. So our service is queryable from the cloud. You don't technically need to know how to code if you know how to manipulate JSON. And it's also multi-chain native. And these are some of the examples of past use cases that's been built using our API. All right. And yeah, our users span analysts and developers. Now, that's a rough overview of what the service provides. Let me give you a quick demo of how you can build something like this very quickly using the API. Of course, like I don't have a UX UI team behind me that can help me build this beautiful UI. So I'm just going to build a table here. This is actually powered by Ant Design. And it's a very, if you know React, it's a very simple React component with just one component here, the balances component, which has a table, right? And this is live right now. So so these are dummy data that I filled in, like using my dummy data source. So let's go through the chain of component hierarchy. In your app, you have the balances component, and the balances component itself just renders a table, which you see here. And the table has a couple of fields. And the data source is supplied the dummy data, which is under here, I believe. And the dummy data is literally just, fake coin. That's the contract name or the name of the token. If I change to fakey coin, I don't think it gets this one. There we go. It renders here as well. So yeah, this is the dummy data that we're using. So how do we get live Web3 data using the API? It's very straightforward. If you are familiar with React, how it goes is that you want to set a state. and we'll be putting our state in this. And then the next thing you do is to get an API key. I wouldn't go through with you the process of getting an API key, but I've got my API key in my environment variable, which is here. I wouldn't really click into it because that would expose my API key. But once you have it in there, you can use your typical process.m. So my variable name is this, right? So I'm just pulling this variable, which becomes my API key here. And then this is the covalent endpoint that you're going to call. So you can call this whatever, but the endpoint itself is API HQ. I have not memorized this, obviously. I'm referring from my notes. And here is the chain ID, which is sent down as a prop, and I'll go through that in a bit. The address, which is also sent down as a prop. And we're calling the balances v2 endpoint. So this is the URL query string. And if you copy this and paste it onto the browser, supplying your API key, you can get the JSON response as well. In this case, we've got this endpoint, and we're gonna make a call. And if you're familiar with this, use effect, we're using an effect hook to make a call with the Axios library. Get balances endpoint. Okay. And then we're going to set data to be, I know what the response looks like. So I know it's supposed to be within the data property and having another data property, and it's the items that we want. Now, we are almost there, but this requires an authorization using the API key. Notice I haven't passed in the API key here yet. And what we need to do is to create an authorization object, a very simple one using basic auth, which follows this structure, right? Yep. So this is your authorization object that you pass as your second argument in the get function. And I believe here you will need to add a to prevent the infinite loop. Yeah, I think that's fine. And then it should be able to, let's say you console log the rest object. Let's see what we get. Oops. Encountered 2 children with the same key. Oh, I think it is this field that needs to be changed here. Let's say I use data dot what is the Data is undefined, but okay. Maybe I'll take this out. Let's see. Each child in the list should have a unique key prop. There we go. So we see that the get get call is returning 404. So what is the issue here? Let's take a look. Maybe it is I think it might be missing a trailing. Yep, we've gotten the data. And classic mistake, I keep making this error. So yeah, so don't make this error next time. So we got the data here, and as you can see, it is the response is in res.data.data.items, res.data.data.items. Don't ask me why it's designed this way, but there we go. We have the token that we want, and the address that I used was this random one here, I believe. Oh no, it's not this one. Okay, let's use this person's address instead. Call it again. I'm gonna ignore this same key thing, although it bothers me. Okay, and then we see that there's a couple of coins, right? And the data is being fetched. Now, all that we need to do is to change the dummy data to the data. And there we go. We've got the balances of this wallet. 47 Atom. Here. Three. Am I calling the? Oh, there we go. It's because this is an address that gets updated quite frequently, so the balance has changed. As you can see, the balance was 3.8 now, and I think previously it was 3.7. Let's refresh this. 3.7994. USDC 0.207, and another IBC GUSDC 0.001538. I'm not sure why this shows different data. I might need to dig in to find out the reason why. Maybe let's do it now. 253. Or maybe this shows the value. Could it be? That's okay. Let's move on. The purpose of this quick example is to just show you how you can, using one API call, you can get all the balances of this address, right? So what else can you build with the API? Now, if you go I'm gonna drop this link. This is an article of how you can call all of Covalent's endpoints in from the comfort of your Postman collection. Oh yes, LPX, good point. Indexing there's a 2-block time delay. So maybe what was reflected was because there was a change in that balance and it's not reflected instantly on the API. So that's also a frequently asked question. What is the latency of the Covalent API? And it is 2-block times, 2-block production times, which I believe in the context of Evmos, 1 block is produced in 9 seconds. So it's 18-second latency. So if you follow this Postman blog post, you'll be able to fork the Covalent Postman collection. And once you supply your own API key, you'll be able to see something like this. I'm using my own personal workspace because it's got my API key inside already. So as you can see, you have all these kinds of endpoints that you can call. You have NFT endpoints. Let's say you know you own some orbital apes, right? Which goes by this contract address. Orbital apes. Oh shit. Contract address. You copy it and you paste it inside here. And also, you happen to know, okay, 9001 is Evmos mainnet chain ID. You happen to own, let's say, token ID 2182, right? And you're just curious, like, so how many transactions have my token gone through in the past? Obviously, you can get the same data from Orbital Market itself or any marketplace. They all show that, but this is a way for you to get it programmatically. So for your token number 2182, you can see that it's gone through quite a few NFT transactions. So this is one transaction. You can see how data rich this is. Another transaction. And another one. And just like how I did with this table, you can convert this data response that you get here into a table. And you can see like how many transactions and from who to whom on which date, etc. So it's very useful for building NFT galleries or pages on an NFT wallet, for instance, right? Another one that I want to show you guys is how do you build like these pools, liquidity pools on Uniswap, for instance, right? You can use our XY equals to K endpoints. So on our docs, it actually shows that these 3 dexes are supported: Diffusion, Chronos, Evmos-Swap. I've tried, it works. But from the UI of the docs, you can't select the DEX name here. So this is just a front-end issue, which I'm getting my team to fix. But you can actually just call, see, diffusion as the pool. And I'm gonna fetch the data live again so that you can see it. And this is the liquidity pools on diffusion, arranged by its TVL. So let's take a look at the first pool. You have Rep Evmos and a USDC seller pool, right? And it's got a 24-hour swap count of 2337. It's got total liquidity here, volume, fees, etc., right? Which directly allows you to build this chart here. So this is obviously Uniswap, but we can build the same thing for diffusion.info, info.diffusion, for instance, right? And yeah, so all these pools will have very granular, detailed information. Of course, you don't need to build front-end UI. You can use this information programmatically to create a trading bot, for instance, right? And then we have certain other tokens like USDC on XLR, wrapped Evmos here. Now, if you want a bit more detail about each of these pools, we have another endpoint to use. You click on one of these. How do you build this chart here? A time series, right, of all of these liquidity, volume, and fees. So that requires you to find out the pool address of this, and you can get a pool address from here, right? Like let's say your pool is using the XY+K pool endpoint, you want to find out the top performing or most active pool. You supply this. Hope this works. There we go. And then we have even more granular information about this pool. You see the, 24-hour volume, fees, etc., etc., and also a volume time series, 7 days time series. And this is an array of objects, classic time series, and it gives you the volume for each day. This was 1st November, 2nd November, 3rd, 4th, 7 days, right? And then you have a 30-day volume time series starting from 8th of October, yada, yada, yada. On top of the volume time series, we have a price time series, 7-day, and there's a 30-day. It allows you to build literally this, right? Of course, we don't have that far back, but you can build 7 days and 30 days. Yep. And then if you want to find the transactions within this pool, you can use transactions for, no, it's not for wallet. Yeah, this is transactions for the pool itself. Like using the same one we did, let's try it out. Chain ID 901. These are all the transactions that has gone against the, I believe that was what, USDC wrapped Evmos and USDC pool. And here we've got an act. An act, you can interpret it as the event. A lot of remove liquidity events. Yeah, so each of these will enable you to build this little table here. So that's the power of XY+K. Now, there's certain like base data, which is pretty interesting as well. So if you want to find all the log events of a contract, you can use this one, and that will give you all the log events that the contract has emitted. And if you want to get a block height between two dates, right? You can use this endpoint. And that's about it. That is the sum of our product offering that I've gone through with you guys. And is there anything else that I want to say? Yeah, for this hackathon, you know, there's quite a big prize pool. And what we hope to see is, you know, developers with good front-end chops, right? Using our API to build visualizations or charts, etc., and very good UI, dApps with good UI. And also, if you can build a backend, Solidity backend, and deploy a contract onto Evmos, that will be even more superb. With all these data, you can easily also do some cross-chain compatibility stuff, like not I suppose like function-wise, this is only a read portion. So what I see is that, for instance, if you have a bridge, this using these endpoints will speed up you developing certain pages of your bridge. Like for instance, if you click on, oh, what's my address for my wallet? But of course, the actual writing to the blockchain is not covered by the Covalent API. You still have to use other methods to do so. And that is, I suppose, the, well, one limitation of the API. Okay, that's all I've got for you guys here. And let's move on to the Q&A.
We had a question earlier here from Nikos saying, if our app is making right calls to contract, like minting or trading, what is the best way to utilize Covalent and get fast response from the action that has been done?
Making right calls to contract. So we used to have web sockets. I think we still do have web sockets. I assume that you want close to real time kind of like response, right? So let me just pull it up. So you can check out the how to implement WebSockets here. And that will get you, I think that's the fastest way to get what you need, which is an event that's kind of transpired on the contract itself. The other way is, of course, just to regularly call the API, perhaps certain endpoints. Of course, using JSON RPC and stuff, I believe you can also subscribe and listen to certain events, which is outside of what we provide. So I think the niche that we have is basically getting historical aggregated data. Yeah.
Do we have any other questions? Please feel free to send them in the chat or just turn your microphone on and ask.
Yes. If you have any more questions, feel free to ask. Don't be shy.
If not, maybe we can get some general advice from you, Leibing, in terms of building. I mean, you've already, oh, we've got one here. So it is not bad practice to use an additional RPC and utilize Covalent mostly for the historical data.
Of course not. Please use as many data sources as you can find, because each of these serve different purposes, and you'll find that some use cases are easier built with Covalent and are prohibitively tedious with RPC, whereas some use cases are not covered by Covalent, whereas pretty simple with RPC. So depending on your use case, feel free to use whichever. Thank you. Good question.
Amazing.
Yeah, Emma, you were saying about
Yeah, so I was just
advice,
going to
right?
ask if you had any other advice for all the hackers building, and I mean, you've already talked a bit about what kind of thing you want to see, but maybe some general advice might be helpful at this stage.
I think what's unique about the Evmos ecosystem is, the stuff on the Cosmos side as well. So I guess, and that takes a bit, the learning curve is a little bit steep for that if you're coming from an EVM environment, which Evmos abstract away for you. But I think to build true novel dApps, which of course we all hope to see in this hackathon as well, I think it's worth investing your time to learn more about the Cosmos ecosystem. Yeah.
We also got a question here from Ilya asking any info regarding covalent indexing Cosmos data side, not only.
So this question has been floated up to Ganesh, the CEO of Covalent, and he was doing a technical feasibility of it with the CTO. But I think right now we are leaning towards no, because there is very different data structures between these two ecosystems. And I guess we've chosen our specialization at this point. Although, like my feeling is the same, like we're missing out on a huge market and also possibility there, but yeah, need to see how the engineers respond to this problem, I suppose.
Thanks for that, Leibing. Elendu is saying that they missed the beginning, and they were wondering if they could see your VS Code or JS on how to use the API to play the tables.
No problem.
Maybe.
I will, let me just share with you.
Be available as a recording, but
yes, but I've got this other resource that you can check out, Web3 components. We changed the directory recently, so. So this is actually a component library that we built that gets you literally what I did, right? It's a token balances. This is a token balances component. You can dive into the code to see how this is being called. Instead of Axios, it uses fetch, which does the same thing. And in mine, I kind of abstracted away the inner wiring, but the inner wiring is exposed in this one a little bit. And also, apart from that, you also have all your ERC20 transfers, right? And a token holders component as well, which you can just star, fork, and reuse. So I'm gonna share this in the chat also for anyone that needs it. Yep.
I will also link all the resources shared by Leibing and the Discord later. So that's all going to be available for everyone.
Yeah, if not, all these are very great questions, and thank you all guys for coming. This notification keeps popping up. Thank you all guys for coming. I think just enjoy, have fun. It's going to be the end of the year soon. Don't work too hard. But really hope to see quality submissions still. Again, like if you've worked on a past project, all we need to see is that you built on new features within the duration of this hackathon. And as long as you can like show to us that you guys have worked on new features, then you do stand a chance to win the prize. Like if your project is good, right? So yeah.
Thank you so much, Leibing. That was a great workshop. Hope everyone else enjoyed. And yeah, please feel free to connect on Discord, and I will send my Calendly there as well for any one-on-one talks and guidance and what might be needed. And I will link Leibing's resources there as well. So yeah, thank you everyone. Have a great day, whatever the time is where you are, evening, morning. And thank you so much for coming, Leibing.
Thank you, Emma, for hosting this. It's so nice. Take care, guys.
Bye. Thanks, everyone.
Ciao.